Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to our ideas on geometry and the introduction. One big thing that you have to understand with geometry is the vocab is just extremely important. And you'll hear me say this many times, but mathematicians are not really super creative when it comes to naming things. So we really are going to have very simplistic names. So first of all, part of geometry, you have to have an image to define. So what is a point? Can you define a point without drawing a point? So it's kind of hard to do that. So this is obviously a point. We are going to just a random location. It has no size, things like that. You're going to label points with a capital letter. A, B, C, I don't care. So if we call this point A. Now lines, and a lot of times this is actually just my compact mirror thing. I just use something random for a straight edge. So let's say we wanted to draw lines through A. How many lines could we draw through A? Well, I could draw this line. Now a line has to have arrows on both ends, right? I could draw that line. I could draw a line going through A here. Notice how I'm making sure they're straight, just a random straight edge. You don't need a ruler. In fact, I like not having a ruler for geometry because it places focuses. I could keep doing this all day. How many lines could I draw through A? And the answer is as many as I want. Could I have drawn them longer? Well, yeah, I mean, I could have drawn them till they went off the edge of my paper. That's why I put the arrows on there. So it's really important that we understand exactly what the idea behind a line is, and that it's not measurable. It just keeps going and going and going forever. Okay, so what about points B and C? Now I want to draw as many lines as possible going through B and C. Not just B, not just C, but both of them. So I'm going to come in here and I'm going to line this up and okay. Could I have drawn a different line? No, I couldn't have. Which actually brings us to the idea of the definition of the fact that a line is determined by 2 points. Could you have more than 2 points? Absolutely. Yes, you could. But you have to have at least 2, because if I said, I want you to take off running and run through this spot, well, you could take a lot of paths, especially if like you're, but if I said, I want you to take off running and run through this spot and this spot, well, now I've given you a lot more direction. And so a line is an infinite number of points that extends in both directions with no end, and technically the line has no thickness. So, I mean, it's not, I know that whenever you go in and make you computer things, you can make it bolder, but technically the line has no thickness, so technically you couldn't walk on it. Like it's not even the width of a hair. Okay, so a point is labeled with a letter. A line needs 2 points. So what about a plane? And I'm not talking about an airplane. I'm talking like a flat plane. Your desk is a type of a plane. The table that you eat at, the floor, those are all types of planes. And a plane, they use like a 4-sided shape a lot of times to kind of draw it. And you're going to need 3 points, not all in a line. Obviously 2 of them are going to be in a line. Like A and B are in a line, B and C in a line, A and C in a line, but A, B, and C are not all 3 in the same line. So, and then they're going to use a lot of times they're going to call it like plane R, and they'll use like a capital letter for it, or plane ABC. Now, the ceiling and floor are parallel planes, as in they never touch, but your north wall and your ceiling, they intersect. In fact, they intersect at a line, because that's that corner, right? Like, look at it, you can kind of picture that line. So planes can intersect, planes don't have to intersect, things like that. But if you think about it this way, this is why a three-legged stool never wobbles. It may not be flat, it may not be comfortable to sit on, but like, you know how if you have 4 legs on your chair, you can make your chair wobble? Can you do it if you only have 3 legs? The answer is no, because 3 points determine a plane. So, kind of a interesting little idea there of why if you want to build a stool that doesn't wobble, just put 3 legs on it. Now, I'm not saying that you don't want to space them out because you don't want them all in one line, otherwise it won't stay standing, right? Okay, so what is the difference between a line segment, and a ray? Okay, well, a line, and I'm going to draw these horizontal, is not just going to go from A to P, it's going to extend past them, but it's going to pass through A and B. Whereas the line segment, I'll still use A and B. So we have a point at A, a point at B, and the line segment starts at A and ends at B. Versus a ray, you can think of it as like sunshine, you know, a ray from the sun. Okay, so here, the notation for this, we have our 2 letters, right, for our line. And sometimes they'll go ahead and they'll give us a cursive little letter on it. You could also name the line like that. So we could name it AB with this line, and I'm drawing it very big. We could name it AB with the line over it like that. So now there's no arrow, so that tells us it's a segment that it ends, or AB, and it's a ray that continues. So the symbol on top of our letters tells us what we're looking at. Okay, so it's important to know that only the line segment can be measured because the other 2 keep going on. This one goes on in 2 directions, whereas this one only goes on in 1 direction. Now, what if you were to draw ray XY and YZ so that they go in opposite directions? Okay. Oh. X, Y. I'll make it go to the right. Y, Z. I'm making it go the opposite direction, right? Oh, when we put them together, what do we have? We have a line. Okay? So together, the opposite ends of a ray created a line. And since all 3 of them are on the same line, they are co-linear. Kind of like co-captains, you're captains of the same team. Co-linear, you're on the same line. Okay, so now let's draw 2 rays so that they don't go in opposite directions. Okay, I'm going to draw 2 rays and they're not going to go in opposite directions. So we're going to draw XY and XZ, but not in opposite directions. So XY and XZ. Now what I've done is created an angle. Okay? So we could call this angle X, but I don't like drawing my angle sign like that. I think it looks like a less than sign, so a lot of times I go ahead and draw what's called an arc through it. so that I know that it's an arc. Or we can say it's angle ZXY. So start at Z, middle of X, end at Y. Or angle YXZ, start at Y, go to X, end at Z. Or sometimes they'll put a number in it. They'll put like a number 1, so angle 1. So those are 4 different ways to talk about the same name or the same angle. They just named them. I'm sure you've got your full legal first name, your preferred name. Sometimes you're, when you're in trouble, you might hear your first name and your middle name. That's the same thing with the angles, is they just get named different ways depending on what we have them. Now, technically the rays, when they go in opposite directions like we did before, technically that's a straight angle. And whatever's in the center of your angle, that's known as your vertex. And we have different sizes of angles. I'm sure you remember in junior high, you talked about different sizes, and we'll get back into that here, but just reminding us that this is now an angle with a vertex, and we can write it in different ways. So understanding how to write things in geometry is a really big thing. Okay, but we want to focus on line segments. So I'm going to go ahead and give you a line segment, and it's going to have numbers and letters and all that stuff drawn on it. We have several points on this. So it's a number line. We've seen these before. And I want to know how long is segment AB. So if I started at A and I went to B, or if I started at B and went to A, I don't care which direction. How far did I travel? Well, you could count 1, 2, 3, 4, 5, 6, 7. So we can tell there's 7 spaces. Or we could say 2 minus -5 and use the absolute value of that, because distance is always positive, so absolute value is a distance. And so that's why we get 7. Or we could have done -5 minus 2, which is the absolute value of -7, which is again positive 7. So anytime you want to know the distance from A to B or C to D or whichever, you're just going to take your first number minus your second number, and then you're going to do the absolute value of that. And that's going to get you your number line distance. Okay? So I don't care which way it is, but it's up to you, right? So 0, 5, and 15. Okay, so H, J, K. So I want you to quickly think about the lengths of HJ. Notice how I'm using a segment addition. How long is JK and how long is HK? Okay, even though I drew it a little wonky, we can see that there's 2 spaces between H and J, because from 4 to 6 is 2 spaces. From 6 to 11 is 5 spaces. And from 4 to 11 is 7 spaces. Now, do you notice anything about these 2 versus this one? So if you said, well, yeah, if you put them together, you get the long one. HJ plus JK equals HK. You're exactly right. We can take a short segment plus a short segment, and it'll equal a long segment. Okay? In other words, HJ plus JK. Notice the J is in the middle. That's very important that we're stopping at J and starting at J. Equals HK. because they have to have a shared point, because we couldn't like say, we couldn't do IH plus JK equals IK, because now they don't have that shared point in the middle. So they have to have that short shared common endpoint. Okay, so this is an example of a true statement. In fact, it's so true that it's called Segment Addition Postulate. Postulate's a fancy way of saying something that we know is true, we just haven't done a proof statement for it. It's pretty much just everyone agrees that it's true. So when I said mathematicians weren't really creative with coming up with names, what is the segment addition postulate? When you add segments together, you get another segment. That's really what the segment addition postulate is. So we can actually do that to keep honing in our algebra skills, okay? So I'm going to give us a line. F, G, H. And never assume anything is drawn to scale. They might look 50-50, but they're not necessarily. Given, oh, I need to label it some more as well. And I'm going to give you that GH is 20 units long. Find FG. Okay. FG and FH. We're going to find them both. And I have bad notation. I should have segment lines over them, right? Okay, well, I love highlighters and stuff for this. GH is 20. That's 20 squares long, which tells me that I need to go back to algebra class, because they labeled GH as 24x plus 8. I'm labeling it as 20, so that must be equal. So subtract 8 from both sides and divide by 24, because you always divide by what's in front of your x. X equals 0.5. Okay, so if x equals 0.5, then f to g is going to be 12 times 0.5, which is 6, plus 5, which is 11. So this is now 11. And remember, this was 20, so how long is all of FH? If you said 31, you were spot on. And again, how did we know? Segment addition postulate. So in geometry, if they ever ask you a question about how did you know, you're going to answer with a vocab word, because it's faster than explaining. So that's why you're going to learn your vocab words, because you don't want to write long sentences. Segment addition postulate. That's why I knew FH was 31. Okay. So there is a protractor postulate that says you can use a protractor, and a protractor kind of looks like a half circle, usually has an arc here, okay, and it has angles up the side, and you'll see two sets of numbers, one on the outside and one's on the inside, okay? So make sure that you understand how to read your protractor. So you might see something ask you for the measure of angle BEC. That's what this says, measure angle BEC. And you'll see a drawing of an angle. And E will obviously be in the middle, because it's the middle letter. means B and C will be the outside letters. Okay, now, wherever your protractor has the 0 mark, if the numbers continue all the way to the bottom, you're going to line your E up with the center at the bottom. If the numbers stop even with this bar right here, you're going to line the middle up right there with your number, okay? So you're going to line your protractor up according to its directions. And it's going to have its base matching that. And I don't have my protractor here, that's why you're getting the drawings. And there's going to be 2 sets of numbers. Okay, there'll be, so let's say this comes across at, one number says 77 and the other number says 103. How do I know if this is a 77-degree angle or a 103-degree angle? Okay, well, see how 77 is on the inside? I bet if you look, 0 is on the inside and 180 is on the outside. And so since B is over here, that's our 0. So make sure you start at 0. So 180 is on the outside, 0 is on the inside. We're going to use the inside numbers. Okay. Also, we can tell that this makes less than a perfect L, which means it's an acute angle, so it has to be less than 90 degrees. So an acute angle is going to be an angle between 0 degrees and 90 degrees. So if it's less than an L, you're going to use these numbers. If it's more than an L but less than a straight line, that's when you would use the bigger numbers. Okay, so acute angles stay between 0 and 90. And that said, the fact that we can measure this is a protractor postulate, which means we can use a protractor to measure angles. Okay, it's pretty much given, things like that. So what I would do is, if you are not sure about how to line your angle measuring device or protractor up, ask your teacher. There's 2 sides to every angle: an initial side, meaning the start, and the terminating side, meaning the end. So make sure that you have the initial side lined up with the 0 of your measuring tool, with your vertex being indicated at the center of your measuring device. So there should be a little mark. So again, if you don't know how to measure with a protractor, please, please, please actually do that one in person, because every protractor is built a smidge different. Okay, but we can do the rest of this even if you don't know how to use your protractor. In fact, understanding geometry without physically measuring things is a great thing to do. So here I'm going to have an angle, and this angle is going to be ABC, and I'm going to have another angle, CBD. Okay, I'm going to call this angle 1 and this angle 2. Now, because let's say the measure of angle 1 is 92 degrees. And please always make sure you draw your degree sign. It means something different if you don't, so that's a big part of labeling. I'm also going to tell you the measure of angle 2 is 34 degrees. So how big would you believe the measure of angle ABD is? Why? If you said 126 degrees, you were absolutely correct. But why? Well, you notice that they share ray BC, and because they share ray BC, we can do angle 1 plus angle 2 to get the measure of angle ABD, and guess what that's called? The angle addition postulate. Again, not very creative on naming things, adding angles together. Okay? So, angle addition, segment addition, it just means you add the two small ones together and they make the big one, especially because they have to share that common point or common ray. Okay, now congruency. Congruent is very similar to equals, okay? Your textbook is very similar to the person's textbook sitting next to you, but it's not the exact same textbook. Hence why we would say maybe they're congruent, not the same thing. They match, but they're not the exact one. So there might be a marking that's a little different inside one because maybe your friend might have written with a pencil on page 253. I don't know. So congruent, we're going to use kind of like an equal sign, but it's going to have this little squiggle on top. It means they have the same measurement. Okay, so we have to be able to notate them. So when we have segments, AB and CD, the way that we would mark that they're congruent is that we put a slash through them. If we have more than one set, the first congruent pair has 1 mark, the second congruent pair has 2 marks, 3 marks, so on and so forth. Okay, and if we have 2 congruent angles, meaning they have the same size, like these might both be 3 millimeters long. X, Y, Z, I'm freehanding, so R, S, T. Okay. So I'll do an example of how 2 marks. So they could just put 1 mark in each. Notice it's an arc, or 2. Okay. So written, AB segment congruent to CD segment. Angle X, Y, Z, notice Y is in the middle, is congruent to angle R, S, T. Now again, I could have had more than 1 mark here. I could have put 2 marks and then they would have been the same. Now is a 1 mark congruent to a 2 mark? No, they're not. Okay, so how might that like help us whenever we're seeing problems in our textbook? All right, let me get you a picture here. Okay, measure of angle AED is 82 degrees. Measure angle AEB congruent to measure of angle CED. Okay, so I've got stuff written down here. So this congruent statement, AEB, that one is congruent to CED, that one, and 82 starts at A, goes to E, goes to D. That entire arc is 82 degrees. Wow. I drew a very bad picture. It's all right. Pictures are not perfect. What we care about, though, is I marked both of these that were congruent in the same color. So that tells me this is also 20 degrees. And I notice that when I do the this pink version plus this pink version plus this version, where X is, I'll put it in brown. I put 2 marks there. That I get the entire green arc. So if I put the 3 angles together, in other words, if I add angles, or the angle addition postulate, I get the total thing. So that tells me 20 plus x plus 20 gives me the whole thing. I can now solve for x because I have x plus 40 equals 82. Therefore, x is going to be 42 degrees. Okay, so the measure of angle BEC is 42 degrees. Again, we're not going to get super creative with these things. We're just going to call them segment addition, angle addition, things like that. So I'm going to draw a bit of a crazy shape here. H, A, B, C, D, E, F, G. Okay. If HG equals 11 centimeters and GF equals 8 centimeters, find HF. Okay, well, H to G. H to G, that's 11 centimeters. Okay, and it has 2 marks. So that means this one here with 2 marks also is 11 centimeters. Okay. G to F is 8 centimeters. So that means this is actually 8 centimeters as well. And this is actually 8 centimeters as well. But I want to know H to F. So how would I find H to F? Well, we can see in the labeling that that's going to be HG plus GF will give us HF, because segment addition postulate, we're adding segments together. So 11 plus 8 is 19 centimeters. And I went ahead and gave you the different measurements so that you could see how that might look if we were having multiple different things labeled at the same time. So even though I didn't give them a number, however long E to G is would also be the same length as A to B. So, and C to D is not marked, so we don't know anything about C to D. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.